Okay, so today we got medium problem, number of ways to arrive at destination. So we got a city with some intersections. So we got undirected graph. It's not a multi-graph and it's connected. And then we got some weighted edges, and you want to know in how many ways we can travel from intersection 0 to intersection n-1 in the shortest amount of time. So I think that's just dijkstra and dp. And how it will work, that like one way to get this vertex, and then we push this and this to our queue, right? We process this, and then we get one way from here, and then we push these two to the queue, and then let's say process this, we put one way from here, and then we put one way from here, one way from here, and then we push this twice onto the queue, and then we go ahead and process it. First time we process it, okay, we check that we push this, right? But the second time we process it, if the distance we arrived in at with what am I saying, is the same as the already computed distance there, we have to add the number of ways, so 2, right? And then this way we would get 2 here, and 3 and 4 and 5, I think. No, this is 8, so 1, 2 and 3, 4 from here, so 4 ways, and that checks out. So I guess let's get it. Roads, y, weight, let's call it weight, because why not? Okay, so we created the graph, and then we need to have like vector, how much can be distance, 10 to 9 plus at most 200. Okay, it can be long. Oh my god, I hate that when I have to deal with both of them. Const long inf 1e18, or yeah, 18. And then this is 0, and then vector ways 0, one way to get there with the shortest distance. Maybe initialize to 0, priority queue. And now what I want in there, I want to put like the distance, and then the vertex that we get there, and the vertex that we got there from, so a vector 0, 1 pq. Every single time I'm running this code, pq top first, every single time I'm checking whether priority queue in CPP is max queue, and every single time I forget every single time. Oh, it's mean. Oh, okay, that's great. That's exactly what we want for dijkstra. Let's see. Okay, the edges are from 0 to n-1, so we push 0, we go there from -1, we are going to vertex, so distance there is 0, we are at vertex 0, we go there from -1, right? So int current distance should be long. Maybe this should be long too, I guess. So current distance is equal to PQ top 0, then vertex is PQ top 1, and then parent PQ top 2 and PQ pop, and then if distance vertex smaller than current distance, continue. Okay, if is equal to current distance, then ways vertex plus equals ways parent and vertex, meaning we are not in 0, right? And then we continue either way because already processed. And then finally for const auto, so we iterate over the next vertex and its weight in adjacency list of W long new distance cur distance plus weight. If new distance more than this u. Are we sure we want to do that? I guess I skip this and then I do this thing, and then this u is new distance, and then PQ push UV, no, new DUV, and that's it. Maybe, no, I need modulus here. Ways percentage ways par percentage mod. It should be plus, but okay, and then mod 1 plus 7. Interesting. They're all pushed in, so what's up with this? Now that is extremely weird. so I edit, and now if pool not visited is equal to base v0 if not this if not this, then I guess continue. That is so stupid. Oh my days. Wait. This is all pushed there. It's max. Suddenly it's max. Oh my god. Okay, that works. Great. 6 test cases don't pass, and I don't have a paper again. Why I never have paper, bro? That is crazy. So we got a 0, 1 in 5, 0, 2 in 2, 0, 2 in 1, 1 in 3 in 1, 1 in 5 in 1, 2 in 3, great, I drew that terribly, in 2, 2 in 4, and 3 and 4. Oh my days. So 1, 1. So all of them are 1 except first and then 2, 3. Okay, and what do we want? 2. 3, 4, 5, and that's one way, one way, one way, 2 ways, 2 ways, 2 ways. Output is 3y. If like that, now it will work. Okay, that should pass. It's quite slow, but whatever. graph, min heap, shortest time, path count. I guess same thing. Okay. Like that. Okay. I'm gonna eat after this. I'm hella hungry. Okay, so let's see. Dijstra. Intuition. This almost seems like dijstra, but we need to add dp to count the number of paths with the minimum weight. Do this by using a priority queue in the dijstra, and whenever we process a vertex for which the distance in the priority is the same as the shortest computed distance to that vertex, we add the number of paths we can get to the previous vertex to the current vertex's path count. Time complexity. Okay, so dijstra is like this implementation with priority queue is n times log m. No, m log m. M log m, I think. Further, since number of the edges in the graph number of the edges in the graph m log n, where m is the number of the edges in the graph, since I don't know, since worst case we add each since in worst case we add each edge the number of edges it has, which is m over all summed over all vertices, and point therefore there is at most log m vertices, no, elements in the priority queue, and therefore each insert slash takes all of log m, okay, of n, since we store no n plus m, the number of the vertices, since we store the graph in an adjacency list, and we store shortest paths for each shortest path and the number of ways to get to vertex to get to vertex and the number of shortest paths to get to each vertex. Okay. 22 minutes. Standard medium problem. Goodbye.